Hey everyone, I'm Dr. Surjit Singh. In this session on Python via examples, we will discuss how computer takes decision for us. Let us begin. In this session, we will discuss Boolean constants, variables, and expressions. We will also discuss relational and Boolean operators. For decisions, we will have examples for if, elif, else, and for match case default statements, and also about break, continue, and exit statements. One of the importance of computer is that depending upon the results that we obtain during the course of execution of a program, it can take decisions to choose the course of further running of the program. For this, we have the Boolean data type in Python. The name is derived from George Boole, who has done a lot of work on algebra of logic. Result of all decisions is either false or true. These are the only two possible Boolean constants. Like any other data type, Boolean results can also be saved in variables. In this program, we define two Boolean variables and save them in memory. The print statement shows that sunshine is false. Both the variables are of Boolean class. Greater than is a relational operator and 7 greater than 5 is a relational expression. We know that 7 is greater than 5, so the result of this expression is true and we store it in a variable a. Such statements are known as Boolean statements. In all, there are 6 relational operations. Their result is always either true or false. Note that is equal to is written as two equality signs to differentiate it from the assignment operator. Python has if statement to take decision that is based upon the result of a Boolean expression. This is described in this program. In an if statement, we write a Boolean expression after if and write a colon at the end. A group of lines after this that we indent by 4 steps is called the if block. Then we write else colon and another block of statements that we call the else block. After the else block, the program continues in a normal way. Depending upon the result of the Boolean expression, Python will execute one of these two blocks and skip the other. However, it will print this line in both the cases as it is the line outside of the if statement. The remainder of the division of 6 by 3 is 0, so both sides of the relational expression are equal. The result of the Boolean expression is true, and Python executes the if block to give this output, and it ignores the else part. Now change the values of a and b and rerun the program. Whenever the result of the Boolean expression is false, Python will execute the else part after ignoring the if part. We may note that the else block is optional. If we omit it, if statement operates only if result of the Boolean expression is true, but it will do nothing in the if statement in case the answer of the Boolean expression is false. It simply comes out of the if statement. Now consider another program to find greatest of the three numbers. Second line of this program assigns 4, 7 and 5 to A, B and C respectively in a single statement. This is allowed in Python. We give blank lines in the program for clarity. This time the Boolean expression has an AND between two relational expressions. In this case, its result is true if both the relations are true. It reads that if A greater than B and A greater than C, then A is the greatest. We print it and come out of the if structure. But if this fails, at least one of the two relations of the two sides of AND is false. Surely A is not greatest, so we skip this block and move to elif block, which is short of else if. Now that A is not the greatest, it has to be either B or C. So we check if B greater than C, then B is the greatest and we print B and come out of the if statement. If this is also false, there is no choice left but to conclude that C is the greatest. In our example, 4 greater than 7 is false, so we do not bother to inspect A greater than C to conclude the entire Boolean expression is false. This is true of all Boolean expressions. Once a decision is established, we do not go further. Now that we know that A is not greatest, we check B greater than C. 7 greater than 5 is true, so we print B and come out of the if statement. Note that we execute only one of the three blocks of the if statement. Now change the three numbers and run the program once again. This time both A greater than B and A greater than C are true, so we print A and come out of the if statement. If we have a long list and we want the maximum number of its items, previous method is not convenient as it will involve a large number of nested ifs. Here we assume max number to be minus infinity to begin with and compare it with the items of the list one by one. First value of num is 4. Every number is greater than minus infinity. Therefore, if condition is true, so max number also becomes 4. In the next iteration, num is 3, which is not greater than 4, so we ignore the if statement. Next, num is 7. It is greater than 4, so max num also becomes equal to 7. If statement is not true for num equal to 1, but when num is equal to 9, if is true and max number also becomes equal to 9. Num is equal to 8 is ignored and we come out of the loop and print 9 as the maximum number. Not and or are three Boolean operators. Not false is true and not true is false. For and operator, result is true if both the expressions are true. So we don't proceed further if the result of the first relation is false. On the other hand, for or operator, result is true if either of the two expressions is true. So if the result of the first relation is true, we do not evaluate the second relation. This means that the order in which the two relations are written is important. In case of mixed expressions, not has highest priority. After this, we evaluate all ands or has the lowest priority. Parentheses can be used to change the priorities. In this program, lights on will become true if sunshine is false and vice versa. We can print these variables to check it. Now consider another program. We consider 4 operations plus, minus, multiply and divide between 6 and 2. Match statement has been introduced in Python 3.10 onwards. It replaces multiple use of elif blocks, but is not available in older versions of Python. We input one of the 4 arithmetic operators and press enter. If we input minus, OP matches in this case and we get this output. In the next run, if we give star in the input, we get this output. While if we give slash, we get 3 as the output. In all other cases, the operator is assumed to be plus as the default value. Default case is optional, but it takes care of meaningless inputs. Thanks is printed in each case. A list variable is false if it is empty. It is true if some items are present in it. For this program, data 1 is true, but data 2 is false, so not data 2 is true. Therefore, if list can be used to know if the list is empty or not. Both data 1 and not data 2 are true, so we get prints in both the cases. Consider the for loop for this program. Val takes values 4, 7, 10 and so on, and the loop continues as long as val is less than 18. If we want to break the loop before all iterations of val are over, we can insert a break statement in between. As soon as val becomes greater than 10, we come out of the loop. If we make it greater than or equal to 10, even 10 is not printed. However, if we make it equal to 9, the loop does not break as value never becomes equal to 9. In this program, we have a list of 6 readings and we want the average of its non-negative readings. For this, we define count equal to 0 and then further store it to total. In the loop, the first reading is 3. 3 less than 0 is false, so we skip the if statement. So total becomes 3 and count becomes 1. In the next iteration, reading is minus 7. If is true this time, so we execute the continue statement. This means that we continue with the next iteration of the loop but skip the remaining statements of the current iteration. In the next iteration, reading is 6. So total becomes 9 and count becomes 2. For minus 2 also, we reach the continue statement. So we come to the next iteration in which reading is 0. 0 is not less than 0, so we do not enter the if statement. The total remains 9, but count becomes 3. In the last iteration, reading is 11, total is 20, and count of non-negative numbers is 4. We come out of the loop and print average as 5. But there is a danger in this program. Whenever there is a division, we must make sure that denominator is not 0. If all the readings are negative, count will be 0 and division by it is not allowed. So before division, we must check that count is not 0. If it is 0, we must decide for a remedy. We here perform exit 1. Exit statement is used to discontinue with the execution of the program before it reaches the end of the program. Exit may be used at more than one places of a program. We should use different exit codes for each one of them. Exit code is passed to the operating system, but the display may be different in different versions of Python. Code value tells us about the position where we halted the execution. Code 0 is for the complete running of the program till its last statement. For most of the input lists, there will be at least one non-negative number, and for them, count will not be 0. For these lists, the program will not exit in this way, and we get the exit code 0. Many Python interpreters do not display the exit code, but merely pass it to the operating system. In this session, we discussed about Boolean constants and variables, relational and Boolean expressions, and about if, elif, and else structures, and about match and case structures. We also discussed about break, continue, and exit statements. Hope you enjoyed the video. Please feel free to ask for further clarifications on my email address given below. I'm looking forward to your comments. Please stay tuned for more.